So a great morning guys, great morning. Today we're talking about one of the concept in optics. It's exclusively for lens. So let's see guys here, this is a problem actually. So I have a lens with me. So this is one of the lens. Let us assume here we have another lens here. So this is another lens. Now what I am doing is that I consider the principal axis. So this is the principal axis. Here also this is the principal axis. So I have two lenses. Let us say A and B are the lenses. So A and B are the lenses here. So A, B are two lenses. It have a principal axis. So what I am doing is that right now I take a scissor. I cut down in two manners. So let me first manner I cut down parallel to the principal axis. By taking a scissor, I cut down parallel to the principal axis. And with help of a scissor once again, I cut down the lens in the form of perpendicular to the principal axis. So I am cutting here in the perpendicular to the principal axis. I am cut there with parallel to the principal axis. So actual focal length of the lens focal length is that. So the focal length of the lens is f actually. So this is the focal length of the lens. And here also the focal length of the lens is f. So focal length is also here is f here. So the focal length is f. So now I want to find out after cutting what is the focal length of A and B right now. You want to calculate. So let's see guys here what will happen here. Let us assume we have to get this one. So then after that we will get this. So after that we have to get this. So 1, 2, 3, 4. Finally you have to get this. So we observe that. So there is no change in the curved surface here. I am not impacting anything on the curved surface. So I am not dealing with any cut, anything with the curved surface. So when I am not dealing with the curved surface, I am not disturbing the curved surface. So R is remains the same. I hope R is remains the same. So I don't disturb any part of the curved surface of the lens. So then if R is remains the same, what about F? F is equal to 2F. So F also remains the same. No issue about F. So F is fixed. So what is the F value here? So finally the F dash is equal to what guys? F. So F dash is equal to how much you get F. F dash is equal to how much you get F. Here also F dash is equal to F double dash, triple dash and 4 dash. What you get? F only you get. So each lens after cutting by using scissor parallel to the principal axis, there is no change in the focal length. So that is one of the very important we have to get from this. So I hope people are understood. So what is the thing is that until I don't disturbing this curved surface, I am not disturbing this curved surface. So there is no question about changing the focal length of a lens. And come to this, I want to find out a new focal length. Before that I want to find out actual focal length of this. Let us assume this is R1 is equal to plus R, this is R2 is equal to minus R. So we have two radius of curvature. So left side is a positive radius, right side is a positive radius of curvature, left side is a negative radius of curvature. So we know one of the formula for finding about focal length, 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. So n minus 1. So that is remains in, we don't disturb that. So n minus 1. R1, just now we have to know this is R, this is R. Why? Because so both are symmetrical lenses. So this lens is a symmetrical lens. So radius of curvature of both ends are same. So that is what I am taking a symmetrical lens. So 1 by R is equal 1 by R minus of 1 by minus R. So what will happen resultant of that? So n minus 1 into 1 by R plus 1 by R. So what you have to get guys here? N minus 1 into 2 by R. So what you finally get? 2 into n minus 1 by R. This is what guys? 1 by F. I want F value. So from this finally what is the F value you have to get here guys? F is equal to R by 2 into n minus 1. So let r by n minus 1 is equal to 2f. So one of the equation I have to got right now. So what is the original focal length of this lens which is given that? So the focal length is that r by 2n minus 1, r by 2 into n minus 1. So this is the focal length, actual focal length. Now what I am doing here, I take a scissor, I cut down this lens perpendicular to the principal axis. As a result, what will happen now? So see guys, when we have to dealing with the perpendicular to the principal axis, so what will happen to this? So it is break down into two lenses, no doubt. We have two lenses, but keep in mind that in one side we disturb the curved surface. So curved surface you have to disturb one side. So this is the getting part. So other part is that. So this is the other part you get here. So this is the other part guys. Other part you will get this. So we have two parts will get. I am taking any one of that. Let us say the focal length is f dash. Let us assume the focal length of this lens is f dash. So f dash I want to calculate. So before that, what are the r values here? So r1 is equal to how much guys? Minus infinity. r2 is equal to I don't disturb. So that is minus r. So I have to substitute in the same formula. So what I have to got? So let's see guys here. So 1 by f dash. So what is the resultant after cutting the convex lens? Focal length, that is f dash. So 1 by f dash is equal to n minus 1 into 1 by r1. So what we got guys? 1 by r1 minus infinity plus minus of, sorry, this is minus, no, plus only, no? So plus infinity. Why? Because this is positive x-axis, not plus only. Okay. Minus 1 by r. So what have to got here? So n minus 1 into 1 by infinity becomes 0 guys, minus or minus plus 1 by r. So what I have to get? N minus 1 by r. So that is the value of 1 by f dash. So what I want actually? I want the f dash value. So what you get finally? So f dash is equal to r by n minus 1. R by n minus 1 you have to got. So the focal length of this one is equal to r by n minus 1. So r by n minus 1 already we have got the value. So 2f. So r minus 1 is equal to what we have the value 2f. So which means that when you have to cut down a length by using a scissor or anything perpendicular to the principal axis, the after newly created lens have a double that of the focal length of the original. So let us assume the focal length of this one is that, let us say 40 centimeters. So as a result, after cutting perpendicular to the principal axis, the focal length of this one become what? 2 into 40, which becomes 80 centimeters. So double that of it. So that is the great thing we have to found here guys. I hope you understood. Thank you.